So in 3.3, you're going to be solving and graphing systems of linear inequalities. Now remember, inequalities have an inequality symbol, like a greater than or a less than or equal to symbol. And you have two equations, or two inequalities, and you're finding out the possible solutions. Now the only way to find this is by graphing, because there are going to be infinitely many solutions to these systems. So a solution of a system is an ordered pair. That is true for both of the inequalities. And realize, again, that the inequalities will have many possible solutions. That's why we graph, to show all the possible solutions. So make sure that you can determine if an ordered pair is a solution of the system of inequalities. You can graph the system of inequalities, and you can solve the system of inequalities. So here is some information that you might need to know. When you graph a line that corresponds with an inequality, you use a dashed line if the symbol is a less than or a greater than symbol. And you use a solid line with a less than or equal to or a greater than or equal to. So be careful and make sure that you're knowing you used a dashed line when you have these symbols. And you're using a solid line when you have an equal to in the symbols. And then realize that when we shaded before, that you're going to have to shade, okay, part of the inequality. So you shade for one, and then you're going to have to shade for the other. And where the two shadings come together, those are your solutions. So you're going to have two different shadings. Now I like to do them in colored pencils just so that you can see the difference, but you do not have to. So on this one here, we're going to graph the system. We're going to make sure that it's in slope-intercept form, and we're going to start at the y-intercept. So at -1 is the first y-intercept, and I'm going to color it red. So at -1, I make a point. Make it kind of big so you can notice. And then I use the slope -3, and so I need to go down 3, so 1, 2, 3, and over to the 1, and I make a point. Now I need to determine if my line is going to be solid or dashed. And because of this symbol right here, it has an equal to, so I know that I'm going to use a solid line. So go to my lines, and I'll look for a solid one. And I connect those 2 points. You want to make sure that you line it up. Alright, and then we did have to decide which line to shade it on. So if I come back up here to the front and I replace, I want to pick a point, and I like to pick a point, any point, and I will choose 0, 0 as long as it's not on the line, and 0, 0 is not on that line. So my question is 0 greater than or equal to -3 times 0 minus 1? Okay, so then realize my symbol's not exactly right, but I have 0. Is it greater than or equal to 0 minus 1, which is -1? So is 0 greater than -1? And the answer is yes. So I'm going to shade on this side of my line where 0 is. And remember, 0, 0, that point is located right here. And this is a true statement. So it means I'm going to shade on the line, on the side of the line where 0, 0 is located. So I'm shading on this side of the line, and I'm just going to shade it in kind of generally right now because I'm going to need to mark the other line too. So I'm on this side. So the next part I do is I go up to this one, and I'm going to make another line. And let's do blue. And I start at the y-intercept at 2, and my slope is 1. So rise 1 to the left 1, rise 1 to the right. And you notice that it's going to be a dashed line because it doesn't have the equal to symbol. Okay, so that means it's going to be a dashed line because the inequality does not have an equal to. So let's find a dashed line Make sure you have arrows in both ends, but I have a dashed line, and it extends out in both directions. Extend it out. And then I need to pick a point for this one. So I pick another point, and it doesn't matter again which one you'd like to pick, but I'd like to pick 0, 0, just because it's easy. And so is 0 less than 0 plus 2? That's my question. So is 0 less than 2? And that's true. 0 is less than 2. So it needs to be, I need to shade on the side where 0, 0 is located. So I shade on this side of the line. So I'm going to use this color. So I'd be shading on this side of the line. Okay. Now where do those two lines meet? Where do the shadings meet? Well, the shadings of the two lines, they meet over here. They meet from this location here all the way over to these locations. And so you would shade in all of these pieces right here. So realize the stuff in the multicolored shading, those are the possible solutions. So realize it's infinite many solutions. They keep going on forever and ever and ever and ever, all the way on this side and past what you can see on the graph. So beware of that all these here are possible solutions to your graph. So make sure you watch this. We're looking at the following system of inequalities. We have y is greater than 3x plus 4, and we have 2x plus 3y is greater than or equal to 12. So make sure you're watching this video, and you can do that at your own time. And check your answers and watch how they graph. Now on this one, you notice you have 3 inequalities, and that's fine. One of them is x is greater than or equal to 0. So that means that on your x-axis you find 0, and all the numbers greater than 0 for x. So it's all the ones on this side of your graph. So you can draw a line. It's going to be a solid line because it's included, and it's just on the y-axis when x is greater than 0. And you pick a point, like you can't pick 0, 0 because that's on the line. So pick like 1, 0. Is 1 greater than 0? Yes, so it means that's the side of the line that you'd be shading on. So I'm going to shade on this side of the line, and it's all the points on this side of the line. Whoops, just went over a little bit. So all the points on this side of the line. Okay, and then I go to the next one. Y is greater than or equal to 0. So again, it's going to be a solid line on the x-axis, and it's all the numbers greater than 0. So I'm going to be shading all the numbers greater than 0, and that's all the ones on this side of that line. So not going below the x-axis, but all the numbers greater when y is greater than 0. So all over here. And you already see that where the green and the yellow are, that is where they're combining. And then we have to do this second equation, or this last equation here. And I need to get it into slope-intercept form. So what I'm going to do is I'm going to subtract the 4x, leaving me with 3y is less than or equal to negative 4x plus 24. And then I'm dividing everything by 3. So y, and be careful, it's less than or equal to negative 4/3 x. And 24 divided by 3 is 8. So now I can graph that line. When the y-intercept is at 8, make a point, and my slope is down 4 to the right 3, and make another point. Now we notice it's also going to be solid, so you notice this line is also going to be solid, and we just connect those 2 points with a solid line. And I pick a point like 0, 0, and I determine whether or not it's a solution to the system. So is 0 less than 0 plus 8? 0 is less than 8. So that is true. So that means that 0, 0 has to be a point included on that. So what I'm going to do now is shade the region that is true for that, and that's all the points on this side of the line. Now do you see where all 3 points, or all 3 shadings are the same? You see the green, the yellow, and the blue? Those are the possible answers to the system. So let's get another shade of color, be very specific on where those solutions are. So I'm going to make it purple. And the purple here, you can tell that's purple, from the x-axis to the y-axis to the slanted line. These are all possible solutions to the system. Everything inside of here are possible solutions to that system. Now the system can be more than just 2 equations, so beware of that. Now watch this video of it graphing and make sure that you understand it. Pause it as you need. So on this one, you're dealing with a heart rate. A person's theoretical maximum heart rate is 220 minus x, where x is the person's average age in years, and it's between 20 and 65. And when a person exercises, it's recommended that a person strive for the heart rate that is at least 70% of the maximum and at most 85% of the maximum. All right, so if you're making a poster for the health class, you want to write and graph a system of linear equalities that describes the information above. And then part B, a 40-year-old person has a heart rate of 150 beats per minute when exercising. Is the person's heart rate at the target zone? So that's what we're looking for. So what do we know? We know that x has to be greater than 20, but less than 65. And we know that 0.7 is 70%, and 220 is the maximum minus x. And then we have 0.85, which is 85% of the maximum of 220 minus x. So that's what we know. We know the person's age, we know the person can be at most 65, and the target rate is 70% of the maximum rate, and at most 85% of the maximum rate. So we're going to graph these. So this is the information that we have. And what I did over here, it's easy to find the x is greater than 20 and less than 65. And I went by a scale of 20. So 20, 30, 40, whatever, all the way up to 220. Okay, so what I did first was distribute the 2 bottom equations and simplified it, so I got y is greater than or equal to 154 minus 0.7x. And the other one, y is greater than or less than or equal to 187 minus 0.85x. So if you notice the y-intercepts for both of them, the first one, the y-intercept is at 154, which is about right here. And the other one, the y-intercept is at 187, which is about right here. And what I did next was find the y-intercept. Now to find the x-intercept, I replaced y with 0 and solve for x. And they both end up at 220. Now notice that they're solid lines. So solid lines for both of these equations. We go through these locations. Okay. And then I have the 2 equations above is greater than 20 but less than 65. So the greater than 20 has to be bigger than 20 but less than 65. Now remember, I went by 20s here, so 65 is really close to the 60. Okay, and then you need to pick points. Which points are solutions? When it's greater than 154 means it's above this line. So above this line would be up in here. Okay? Alright, so up in this location. However, this one wants to be below 187. So that means instead of being above it, it's going to go below it, which is all the ones below that piece. Okay? And then, of course, greater than 20 means that it's going to be bigger than 20, all the ones over here, but less than 65. So do you see where all the ones intersect each other? Right here where this darker spot is, this little four-sided figure here. So the solutions are going to be right here, where all the ones are bigger than the 20, but less than the 65, and fit the other two inequalities. So right there in that center location would be the points that are the solutions to this system. So the last part here is you want to substitute it into the system and determine whether or not these are solutions or possible solutions. So what I'm going to do is take those two equations and I'm going to substitute in the x with -1 and the y with the other coordinate, which is 2. And then I solve. Is 1 greater than or equal to -1? Well, yes. So then I check over here. Is 2 greater than -2 plus 2? So is 2 greater than 0? And that is a yes also. So this is a solution. And then we go over to this other side and we try the same thing. But we replace x with 0. And down here, the y was 0. And so also with the x. So is 0 greater than 1? -1? Well, yes. And then you check over here. Is 0 greater than 2? That's a no. So this is not a solution. And you try the same thing with the 1. 1 and 4 is what I'd have, but the x is 1, the y is 4. And I want to know if the statement's true. So is 1 greater than -1? Well, yes. And my question in here is 4 greater than, that would be a total of 4. So is 4 greater than 4? No, it's not greater than, it's equal to. So it's not a solution. And you try it one more time. 2 and 7. So the x gets replaced with 2. The y gets replaced with 7. There was no y in that first one, so you just leave it out. So is 2 greater than -1? Well, yes. And you check the bottom one. Is 7 greater than 4 plus 2, which is 6? Is 7 greater than 6? Yes. So it's a solution. Make sure you watch the blank notes because they're on there. It's under the blank notes section, but all these ones that are extras have them on there with the voices recording what's going on so that you can pay close attention. This is just me going through it. But the blank ones on your notes are on the blank notes on Moodle, and you can follow those. And that gives you just a few extra examples that could help you out.